We've considered centripetal acceleration previously. Here we're going to consider it again and combine our centripetal acceleration that we need for a particle to keep moving in a circle with a tangential acceleration, as this particle might be speeding up or slowing down. That means that the total acceleration that some point on this rotating body might feel at any given point in time is going to be the combination of these two vector quantities. As a vector, you have to do a vector sum, which means that the magnitude, since these two things are always going to be at right angles to one another, can be given by this sum of their squares, followed by taking a square root. And then the direction, you can do an inverse tangent of one over the other to get a direction. We'll remind you that the centripetal acceleration is given by v squared over r, where v is that tangential velocity, which can also be expressed as r omega squared because v equals r omega. Our tangential acceleration, which we now know, is r alpha. That means that if you want to find my overall acceleration, I can find the centripetal acceleration, the tangential acceleration, and then combine them as a vector sum to get our overall acceleration. And that pretty much rounds out our consideration of basic rotational variables. Here's a nice comparison between the linear quantities that we've had before in displacement, velocity, and acceleration with our rotational quantities that are new, theta, omega, and alpha, along with the relationships between them where s is r theta, v is r omega, tangential acceleration is r alpha, and the vector relationships. S is theta cross r, v is omega cross r, at is alpha cross r. To remind ourselves, centripetal acceleration is v squared over r, and we have these relationships for things that are spinning in circles or undergoing periodic motion of some sort, where we can say the period or the time to complete one revolution is 1 over the frequency, which is 2 pi over omega. We have the frequency in terms of omega as well. We have our centripetal acceleration in terms of omega if you'd like it. Lots of fun stuff there.